All right, everybody, we just got our okay to start the final planetarium show of the day. And to make it feel a little bit more comfortable in here in the planetarium dome, I'm going to change the lighting in here. And welcome, everybody, to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls, I'm a person and I'm standing right behind you. Hey, good afternoon, everybody. Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one really big screen. I just want to let you know that I'm a real person. And what's really special is that this final show that we're doing here today is completely different from all the other ones that we've done here. This show is called Tour of the Universe, and it's completely live. So, what that means is that you're going to be hearing my voice for the next 30 minutes as I free fly us through space. And we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So, hopefully, by the end of the show, you won't have an existential crisis of where we are in space. But just a forewarning, we're pretty small in the grand scheme of things, so just a forewarning. But before we get started with the show, I do have to go over some quick house rules just so that we're all on the same page and have a good time in here. First off, folks, there's no food or drinks allowed in. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light, now is a good time to put those devices away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. And folks, if you need to exit early during the show, the exits are always going to be at the very top of the planetarium. So always make your way up the stairs to exit. If the stairs are too steep for you to climb, do not worry, just remain seated. Once the show is over, we'll have a staff member escort you to a lower exit so that you don't have to climb those steep stairs, so just stay seated for a little bit longer. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling all the way towards the edge of the universe. At least not more than the usual. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. All right, folks, let me regain our controls here. And like I said, we're going to be starting off pretty close to the Earth. We can see all the city lights down below. But we're starting off just a little bit above our planet here at this amazing spacecraft called the International Space Station, or the ISS. And a lot of people tend to ask me, hey, Christian, what's the International Space Station? I always heard about it in the news and online, but I don't really know what it is. Could you explain it for us? Well, of course, folks, the International Space Station is a research facility. Pretty much what that means is that this is a laboratory that orbits around our planet Earth. And they conduct many different types of science experiments up here. Some of the science experiments they'll conduct are things like what happens when you try to grow plants in space, which way do the roots grow with less gravity? Another one that they've done is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently in space? And one of my favorites is where they had two identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for a year. After that year, they compare and contrasted the two twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have as much gravity working down your muscles all the way up here out here in space. And also, folks, our space station here looks incredibly large, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, that's okay. You can also use the entire museum that we're sitting in right now. That's about how big it is. And also, what's really impressive is that the International Space Station is traveling really, really fast. It's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, this looks really far away from our planet as well, but it's not too far either. The International Space Station is only about 250 miles above the surface of our world. 250 miles, that's not too far away. That's kind of like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, not too bad. But to tell you the truth, folks, this is as far as we put humans into space nowadays, only 250 miles above the surface of our world. The reason why is because traveling into space is really expensive. You got to build yourself a rocket ship, buy yourself one, or pay for a ride. And then not only that, you have to get so much rocket fuel, you got to be able to escape the Earth's gravity. Once you acquire all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets quite costly quite rapidly. But, folks, the International Space Station is just the first stop on our tour of the universe here today. So now we're going to see it slowly fade away to the city lights down below. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can see it as it starts to slowly fade away. All right, folks. Now we've zoomed all the way out here and we're able to see our entire planet Earth from this perspective. And I want to let you know that the space program that we're using here inside the planetarium is something that you can go home and download if you want to fly through space, just like how I'm doing right now. The space program that we're using in here is called OpenSpace. So if you go to openspaceproject.com, you'll come across a link where you can download this and you can fly through space. What's really amazing is that this program isn't entirely finished. It's in its beta phase. So there's still a lot of stuff that's being figured out. And this is open source. So what that means is that anybody who knows computer programs, you can add to this software. So if you like building spacecraft models, you can add them if you like, if you're into that. So anybody can add to the software, which is really, really cool. And also what's really amazing is that this thing uses almost real-time data. So all the clouds that you're seeing here, this is pulled from satellites that were taken from yesterday. So this is almost real-time weather that we're seeing here. And because it's pulling from satellites, it uses a whole lot of processing power. So if you have an older computer, you may not want to download it. But if you got something new or a gaming computer, give it a try. It's a whole lot of fun. But we're using OpenSpace in here. And now that we got a sense of what we're using, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions. That brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time that we sent humans to the moon was 1972, so a little more than 50 years ago or so. And what's really amazing is that sometimes here from planet Earth, when you look up at the moon, it feels incredibly close. It feels like you can reach out your arms and touch it. But the moon is incredibly far away, folks. It's about 240,000 miles away from the surface, 240,000 miles away from us. Whew, 240,000 miles, that is a good distance away. Now, some of the people in this room right now may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although we wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, Well, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye bye, moon. So cute. And now, folks, we're going to see the moon start to slowly fade away, just like how we saw earlier with the International Space Station. And just like before, we're going to see it slowly fade away. And I want to add some planet trails so we can keep track of all the stuff out here in space, because again, space is really, really big. And on our journey today, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate images and information available to us. And now the nearest star to us, the sun, is coming into view. So here comes the sun. Do 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 do. And folks, the sun is also incredibly far away from us as well. The sun's about 93 million miles away from our planet Earth. Whew, 93 million miles. That is a good distance away. But in order for sunlight to travel that 93 million miles, it only takes sunlight about 8.5 minutes at the speed of light. 8.5 minutes. That's not too bad. And this is a really good concept to keep in mind because, again, it takes light a while to travel really far away distance. So what's really amazing is that if we're looking at a star that's 70 light years away from us, we're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's kind of like looking back in time in a sense, which is really, really cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have. Right in the middle is our star, the sun, the biggest thing by far. The closest planet to the sun, we have Mercury. Then we have Venus. It's really hot there. And then Earth. That's us. And of course, we have Mars as well, the famous red planet. And these are the rocky terrestrial places where we can actually land a spacecraft on. And then past the orbit of Mars, we have the main asteroid belt. This is where you're going to find the majority of asteroids. And this is what it looked like if I highlight all those asteroids. There's roughly about 1 million asteroids in this region. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. Then we have Saturn, famous for its rings. And then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen. And now, folks, I'm going to be adding some many different spacecrafts that we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. You can see that interaction close to Pluto's trail. Now, all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours. Again, not too bad. But now, folks, it's time for us to leave our planetary scale behind us because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri is going to be the top left star that we could see moving. So this is us right here in the middle. The very top left, we can see a star that's moving relatively close to us. Again, that's Alpha Centauri. And again, 4 years at the speed of light just to reach the next star system to us, folks. But that doesn't put into perspective of how long it would take us humans to travel there. Well, if you were to get in a rocket ship today, made your way over to the next star system, it's going to take you roughly about 8,500 years. Whew. And that's just a one-way trip. But folks, let's stop consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. And again, folks, we're now inside something called the radiosphere. This represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before the early 1930s, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, folks, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. So that 5,000 will be increasing as the years continue. Now, to say if any of them are Earth like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed, created, so we got a few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. And of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers. And I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. And folks, we're now looking down on our Milky Way galaxy. This is the galaxy we live in, and I've got to ask, can anybody see their house from here? And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you roughly about 130,000 years at the speed of light. Whew, it's really, really big. And our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from the side. You're going to notice that we live in a big flat spiral disk of the Milky Way. Kind of looks like a big pancake or a frisbee. And this is important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. And folks, our Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space, where there's one galaxy here in a nice line and another galaxy here in a nice, neat line. Instead, galaxies like to group together in large groups and clusters, or they create voids where there's very few galaxies or no galaxies at all. So we can see some nice galaxy clustering towards the center of our screen here. We can see very few galaxies or no galaxies towards the top of our planetarium dome. So you can kind of think of those galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're looking at right now represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tolley, who compiled this amazing representation over decades of time with the help of other astronomers working aside him. So, big shout out to Dr. Brent Tolley. I love flying through this galactic map. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And as we start to swing around, you're now going to realize that the large scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of the Milky Way Galaxy? Well, if we were to line up our Milky Way Galaxy, it would line up just down the middle, like so. It's about to become vertical. And again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way. But scientists still want to make sure that there's galaxies through the plane of our Milky Way galaxy. So we have this purple survey of galaxies towards the center that you can see. And you'll notice that we are still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these gaps that haven't been filled in yet. So it's just a matter of time. But let's continue pressing on, folks, because now we're going to be encountering these really distant, faraway objects known as the quasars. Now, the quasars are going to be represented by orange dots on either side of the large scale structure of the universe. And the quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a very much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. What we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color coded with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But, folks, we've traveled as far back as the law of physics can physically allow us to go. So we only have one direction left to go. That's going to be back towards Earth, back to home. So let's find a nice entry point to all these quasars and galaxies Yes, right here is a good spot. And let us make our return trip back to planet Earth, everybody. All right, folks, we're crossing the expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes. Now, all of this is preparing us for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope. And there's astronomy clubs all around the world that invite people just like you to peer into their telescopes and see into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But, folks, we made our way back into our Milky Way Galaxy. We're heading straight through this radiosphere, and we're making our way back to our star system, our solar system, our little neighborhood in the vastness of space. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto. And now we're making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back home just in time for dinner time. And that's all the time that we have for today, folks. I want to thank y'all for stopping by and make sure to get home safely.